would like to say that I'm very happy to be back in Katowice for the second time. I've been here quite a few years ago, and it's great to see how everything develops here. And I'm very excited to be in this project together with our Polish and our Norwegian partners. And I'm happy to talk to you today because, as everybody else here on the podium, I'm convinced that schools play a crucial role in computer education. And I think Molly Malika has given a lot of good arguments why computer experience already in schools is important. I might add that even the President of the United States about a year ago has made this point. Basically, he was saying, things like, don't just buy a new video game, write one. Or don't just play with your phone, program it. So we have this problem that many young people nowadays just use computers. A smartphone is, of course, a computer, but they are not really productive with it. And my experience from 20 years of teaching now at the University of Augsburg is that basically the computer skills have not changed very much. I mean, we had 20 years ago, we had people doing an excellent job writing programs. But I also had students, one of them told me he has nightmares when he has to write a computer program. And today the situation hasn't changed very much. So I think that schools play a crucial role at this point. And when I talk about more practical points, which language to use, then I think that at the university, when I'm teaching first-year students, I'm in a similar situation like you in high schools. So if during my talk I talk about students, I include high school pupils. I just don't want to say this explicitly every time. But I think we are basically in the same situation. What kind of language should we use to teach a first programming language to students? And in fact, I think the choice is important, and you'll see what for me are the main points in this choice. But on the other hand, you always have to be aware that if somebody learns a certain language, might go on learning other languages later on. I mean, the language I learned, I don't know, a long time ago, I haven't used very much since, but I have been able to learn other programming languages. So there is a choice to make, but it's not a choice which will affect people in the long run if they want to use a different language. The important thing is that they get started, that they learn the concepts, and then they can apply it also to other languages if needed. Of course, today I want to make the point that Python is also a language which is useful in the long run, and you have heard from the previous talks that Python plays a crucial role in our project. Now, about 5 years ago, due to what I just told you, the fact that computer literacy among our students hasn't changed too much, I proposed that for our physics undergrads, we should have an introductory course on programming. And the first question my colleagues asked was, which language are you going to use? Fortran, C? So these are the languages which you find in science, which are there for a long time. And I was saying Python. And the reaction of my colleagues was basically Python what? So they had never really heard about this language, even though it's not a brand new language. I mean, it's now in its third major version, so it has some age. And still, it's not very well known in the physics community. Well, this is not true in Oslo, of course. It's not really true here. But it's, I think, still true in a lot of places. And, well, of course, I'm not making this point to say that my colleagues just don't follow what's going on in computer science. But there's, of course, an important question here. If you teach a programming language to physics students or even kids at high school who are interested in physics and mathematics, what kind of language should you actually use? I mean, you have to think about it. And the questions you might ask is, well, first of all, is this language a useful language for teaching purposes? I mean, you don't want to start with the most complicated language. There should be a low entry barrier. People should have fun quite early, but still, of course, it should be a reasonable programming language. So having a low learning barrier doesn't necessarily mean that we are talking about a language which is not useful for real problems. Yeah? This is important. I will argue that Python is a language which has lots of applications and is really used in the real world. Then, of course, if we teach programming in the context of physics, of mathematics, at high school, at university, then the question is this programming language useful to tackle scientific problems? Ideally, we would like to have this mixture between computer education and real-world problems in physics, in mathematics. And then, of course, in the long run, is this a language which can be used in academia, in industry? Are people using Python, the language I'm advertising here, in industry? This is something I will come back to at the end of my talk. And I think all these questions can be answered with yes for the case of Python, whereas for almost any other language I know, I would put questions mark at least at some of these questions. So, as you already know, was just written here, but this was said before, the language we're using in this project is Python. It's based on Sage, this project, but Sage is relying on Python. Now, of course, when you ask yourself which language should you use, the first thing is maybe you can ask yourself, what do other people think about this? And this is a quite amazing result obtained by Philip Guo, a computer scientist in the United States. He has taken introductory courses from science departments from 39 US science departments. I don't know how many universities these really are, and you can wonder how stable this is if you take the 50 most important ones or the 10 most important ones. But what you see here is that there are two languages which really stand out. This is Python and this is Java. And then there are a few more which are much less important. Among them, one of the languages which I quoted before, my colleagues were asking about, C or C++. These languages are usually not used as introductory languages. And I would also argue that Java is, of course, a language which, if you want to do so-called object-oriented programming, it's probably the must which you should learn. And a lot of computer science departments use really Java and C at the beginning. But in a scientific environment, I think that Python is a perfect choice. And you see that nowadays the majority of these computer science departments actually use apparently Python. Now, I wonder how this situation looks like in Germany, in Poland, in Norway. It might be still different, I guess, but I mean, that's why I'm here to tell you about Python, so that things change in the long run. So, what are the reasons why I would like to advertise Python? Well, actually, I should say I'm not affiliated with Python in any sense, so it's not like that I'm doing commercial work here. I'm really convinced that Python is the right choice. And the first thing you have to ask yourself is, how available is this language? So do you have to buy something for your schools to teach the programming language? Is it available on different kinds of computers? I prefer Linux, some other people prefer Windows, some people have Macintosh. Is this language you're choosing, is this available on all computers? In fact, it's, I think, not only a question of whether this language is available for the operating system you're using at your school. I mean, in my introductory programming course, usually I have about 50% of my students who own a laptop. And I really prefer in an introductory lecture to have my students have the software on their own computer. They shouldn't come to my computer room and sit at a computer and have the impression that what they are doing can only be done there. they should be able to do it at home, on their computer, just the normal environment they are used to. And for this reason, I think it's really important that a programming language is available on all major operating systems. And this is certainly true for Python, and it's for free, so there are no costs involved there. The second point related to availability is something you know very well. You buy an electronic toy for yourself or for your kids. You want to try it out on the weekend, and you realize, I would have needed batteries, and I don't have any batteries at home. And the same is actually true for programming languages. If you choose many programming languages on the market which are useful for teaching, and you ask yourself, can I use this in my physics class, for example? You'll find out that you would need some libraries which are maybe not available, which maybe costs money. For Python, there's a saying that it comes with batteries included, which means you have a whole bunch of libraries, even the standard library, but also freely available. I've listed this last link here, python.org, which is a place where you find more than 50,000 packages for Python. Not all of them will be useful for you, but in principle, there's a lot of software out there which you can just use. It's free. And I think that's an important point. So whatever you want to do, it's very likely that you can do it with Python. So there are, for example, for scientific work, and we are probably using parts of this also in our project. This is NumPy and SciPy. These are two important libraries which are still actively developed by volunteers. This is, I would say, professional software. This is used also in scientific work. And this can be used also in a school environment if you want to, well, have a physics problem solved on the computer. You don't program the solution of a, let's say, differential equation by yourself. Maybe you even want to hide it from your pupils because you don't want to tell them too much about differential equations. Here you will have functions which just do the work for you. The Vice Rector mentioned the literature in his speech. What if you have students who say, I'm not so much interested in physics, I'm more interested in literature? Now, talking to people in our humanities department, I'm not sure whether just counting words or whatever data mining in literature is necessarily a good idea. That's probably a different issue. But in principle, it's a point which might be important. You have texts, you want to analyze them. There are tools here. It's not only about science in the sense of natural sciences, but if in literature you decide you want to analyze a text, you can do it in Python, no problem. Actually, I regularly do an exercise with my students where we take the Faust from Goethe and we try to find out which is the word which appears most often in this text. We do this in Python. Django is a web framework which connects you to databases. So again, for example, in humanities, if you work with databases, then there is a framework which allows you to give you a nice output also on the web. We do our seminar announcements with Django, so Python is useful there as well. I mentioned Pygame as a library for game programming, more in the sense that you could do some animated presentations on a computer. Pygame facilitates this enormously, and we have already, well, even though Professor Kostur said that animation is not the main point of our project, I think animation still play a useful role. And there are, for example, there's software heavily connected to Python, software called Blender, where people are producing animation movies which really are highly professional. You'll find these on YouTube if you want to look at them. The nice thing for schools is that there are comprehensive distributions available. You can imagine that usually you don't want to install all these libraries for your computers. This is a lot of work. This is largely facilitated by distributions. I would name Anaconda from Continuum Analytics, Canopy from Anthought. These are basically consulting firms who earn their money by consulting. And for the academic area, also including high schools, these distributions are offered by them for free. There are other distributions like Python XY for Windows and some more. The main resource, if you also want to get into Python, if you want to learn Python, is really www.python.org, which is the main website where you find the software and where you find a lot of information about how to learn this language. There's actually also a group of worrying about Python in education, discussion groups, and so on. So you'll find a lot of things there. Now, some characteristics of Python. Well, Python is what we call an interpreted language, which means Python just reads the code and tries to do what you ask it to do. This is in contrast to the classical compiled languages where you write a program, then you give it to another program, which turns it into something which the computer understands, process of compilation, and then you can run the program. Of course, for teaching, an interpreted language is much, much more useful because it gives you immediate feedback. You don't have to go through this compilation cycle. You immediately get an answer, and in the worst case, there's something wrong. And in the best case, you get the result you are interested in. And this supports what I would call explorative coding. So you can ask your students, well, just try it out. And if it doesn't work, modify it a little bit. So you can play around, and I think to learn a programming language, this is a good idea. You need the basic concepts, and then doing exercises, you can try out various things and see whether it works. So for example, in this Python shell, you see I've put here 2 to the 100, 2 to the 100, you get the result immediately, or you could even put 5 lines of code and sort a list of numbers, for example. And this can be done in the shell. Of course, this is not the usual way you would write a large program. But for teaching purposes, this is very nice because you get immediate feedback. I should mention that there are nice graphical integrated development environments like IDLE or Spider, which come with the distributions I mentioned before, so you can do certainly more fancy work. And one of these more fancy approaches is the IPython notebook. You see this on the left side. IPython by itself is a shell which is much more advanced than the one I showed you before. And the IPython notebook is very nice for teaching purposes because first of all, it runs in a browser, so it doesn't depend much on the software which you have installed. You can produce notebooks. You see it here. This is code mixed with text. The text can even contain formulas, which is very useful in physics and mathematics. You can integrate graphics, everything. You can print it out. You can produce HTML, PDF from it. And you can distribute these notebooks to your students. So what I do in courses often is that during the course, students will be sitting there with their laptops. They have this notebook, and they can execute the code I'm discussing in front. Yeah? So they don't have to do the typing while I'm teaching, which will distract them. They can just execute the code. Of course, there's one point which is important. You know this certainly very well, that if you type something yourself, you learn it much better. So a notebook is probably not the best way as an only tool to teach a programming language. There should be exercises where students do the real typing to really learn how to code. But for a lecture, for example, this is perfect. And I should mention that the Sage notebook, which you will see here, during the workshops. This is basically based on IPython notebook with a few modifications. Some more characteristics of Python. I've given you here 3 examples of different languages, Python, Fortran, and C. These program snippets do basically the same thing. Well, they just print out some squares of integer numbers. And my point is not about the length of the code. I could have shortened the C code. I'm aware of that. The main point is if you try to read this code, and suppose you don't know any of these languages, which is the code which is the easiest to read? And I think the easiest to read is really Python, where you can basically read it. What often happens in the exercises I'm teaching is that students have some writing blockade. You're certainly familiar with that as well. And what I usually do is I tell them, okay, what do you want the computer to do? Tell me in, well, I say tell me in German, you would say tell me in Polish. And then I tell them, okay, translate it into English, and now please type it in. And then you're maybe to 90% at the final code. So there's a very natural way to write a program and to reduce blockades. If you look at the C code down there, this line, the 4th line, for e equals 0, semicolon, I smaller 5, semicolon, I plus plus. Well, once you know what it's supposed to mean, it's obvious. But for a student, it's not at all obvious. So Python is a very expressive language. Also, it supports to write readable code. And there's one thing which you might have already noticed. There is code indented. There's some white space in front of part of the code. And in Python, this is really important because the end of the block of, for example, this for loop is indented, and whenever this indentation stops, this block is terminated. In other languages, for example in Fortran, you start with do, you can indent, but you're not obliged to do it, and then there's an undo which will stop the block. Yeah? So you need all these parts. So here you do white space simply because you think it's nicer, and experience shows that usually you don't care too much about it. And your program will be, well, terrible. In Python, well, there is a certain force. I mean, you're not, it's not like you don't have any freedom anymore, but you're obliged to put these white spaces and you get a benefit out of it. In C, you would have to put brackets, which is also, well, one way. You can indent, but still, it's not mandatory. Yeah? And so at this point, Python, in a very natural way, brings you to write nice code. I already mentioned how important it is to have a low learning barrier. I would claim that if you start teaching C simply because C is used in physics a lot, then you will put up a high learning barrier and students will be afraid of programming. With Python, it's very natural to write simple code, and the learning barrier is much, much lower. Of course, some people will tell you, if you tell them that you are going to use Python, that there are other languages which are much better suited. If somebody says object-oriented programming is important, and you should start out with such a language, I'm not sure whether that's a good idea, but I mean, you could argue like this. Then you would say, okay, I prefer Java. Or if you do functional programming, then you use another language. The point is, in Python, you have all these paradigms implemented. So you're not forced to program in an object-oriented way, which sounds very modern, of course, and well, ultimately you will do that. You don't have to do it, but after some time, when you're ready for it, it's there. Python is a very powerful language. It offers you object-oriented programming when you want to use it, but you're not obliged to do it from the very beginning. It is also a so-called dynamically typed language. What does that mean? Well, we often call this duck typing. because if something quacks like a duck and it looks like a duck, it probably is a duck. Some people say it could be a dragon. These are the people opposed to dynamically typed languages. In Python, you're not forced to declare the type of a variable. But that's a good thing or not, can be debated. But it means that one doesn't have to worry too much about it, at least not as a beginner. This is one of the reasons for one criticism which you're likely to encounter if you tell people that you're using Python, and that's that Python is not really the fastest language. But there is a big but. If you're teaching Python, and then usually execution time of your code is not important. The time students are taking to write code, that's much more important. Typically, code which you have produced in exercises will run within a few seconds. The time students will need to write the code will be more like an hour or so. So usually development time can be much more important unless you do really large-scale problems in physics also. So whether a programming language is fast or not is not such an important issue necessarily. And then we have libraries which we can use to speed up Python a lot. For example, NumPy. We can also interface to C, which speeds up things quite considerably. And then there are, I don't want to go into details, but nowadays there are important developments in just-in-time compilation, which will speed up Python again quite a lot. So I think the point that Python is maybe not the fastest language is not really an issue. Now, we already have seen in this nice YouTube video a few testimonials about the use of coding. Now, this is the Python version. We have here the director of research of Google, who says that Python has been an important part of Google since the beginning and remains so as the system grows and evolves. From YouTube, Python is fast enough for our side, so speed is not really an issue, and allows us to produce maintainable features. So you write nice programs, it's maintainable in record times with a minimum of developers. And finally from CERN, so this is really hardcore physics, they say that most developers in the CMS experiment, the one where they found the Higgs boson recently, or one of the two experiments, are physics students looking for new physics in the data. Usually they don't have any formal IT training. Python allows them to be productive from the very start, low learning barrier, you get productive immediately, and to dedicate most of their time on the research they want to carry out. So clearly, in academia and in industry, Python seems to be a useful language. So to conclude, I would like to show you this cartoon. You're flying, how? This guy up there says Python. I learned it last night, and that's the main point. It's not too difficult to learn Python. Everything is so simple. Hello world is just print hello world, as simple as it should be. Well, then the guy down there says, I don't know, dynamic typing. Remember, duck typing, white space, this indentation. Come join us. Programming is fun again, and I can really assure you that Python is the first language where I really had the feeling, oh, this is fun that you can do it in this way. Never happened to me with Fortran or Pascal or so. It's a whole new world up there, but how are you flying? I just typed import anti-gravity. Well, we learned about the batteries included. So far, there's not anti-gravity included in the batteries, but basically tells you that you can import almost everything, not anti-gravity really. The critical remark, that's it. Well, I also sampled everything in the medicine cabinet for comparison, but I think this is the Python. And so I hope that if you are going to use Python in your school, that you'll have a lot of success with it. I think it's a very good choice, and my recommendation would be to really give it a try. I think it's the right way to learn programming at the beginning. Thank you.
Dziękujemy bardzo.